Hi everybody, this is lesson 4.4. The title of the lesson, Balancing Blood Alcohol. In this lesson, we are going away from unit analysis and we will start a lesson that will cover a little bit of algebra or introduction to algebra. So let's read the specific objectives. Students will understand that addition and subtraction, multiplication, division, and inverse operations. Solving for variable includes isolating it by undoing the actions to it. Students will be able to solve the variable in a linear equation and explicitly write out order of operation to evaluate given equation. So finally we get to the point where we'll do mathematics that many of you will find familiar. So let's look at the setting of this question. Blood alcohol content, BAC, is a measurement of how much alcohol is in someone's blood. It usually measured as a percentage. So a BAC of 0.3% is 0.3%. I would like to break this down a little bit, okay? That statement, 0.3%. So as we reading this, I'm going to write that information down. So 0.3%, that means it is 0.3%. All right, or it can be written as, remember the percent means out of 100, so you can actually divide this by 100, 0.3%. You can divide this by 100 to get 0.003, which means it is 3 out of, and then there are 3 zeros because there are 3 places right here, so it's 3 thousandths. All right, that's where this sentence comes in, that there are 3 grams of alcohol for every 1,000 grams of blood. So in other words, if you think about this, 1,000 gram is a kilogram. A kilogram in a liquid form can be thought as a liter of water, like, you know, a Sprint water, 50 milliliters. So 2 of those waters will make it 1,000 gram. And 3 grams is like of pure alcohol is very small. So 3 grams, if you think of a syringe, it would be something like this. So imagine that you dissolved this amount of alcohol in 1,000 gram of in 1 liter of water. That would be that concentration. So it's pretty small. But now check this out. It says a BAC of 0.05%, even smaller than 0.3%, impairs reasoning and ability to concentrate. A BAC of 0.3% can lead to blackout, shortness of breath, and loss of bladder control. So this is actually, that amount of alcohol in blood is dangerous. In most states, the legal limit for driving is a BAC of 0.08, including New York State. All right, so that's the amount. Now, BAC is usually determined by a breathalyzer, urine analysis, or blood test. However, a Swedish physician, E.M.P. Widmark, developed the following equation for estimating an individual's BAC. This formula is widely used by forensic scientists and is given by this. So today's lesson will focus on this equation. All right, now check this out. It has a couple of variables. B is the percentage of BAC, so that's what we're discussing. So B is our BAC. The N is a number of standard drinks. A standard drink is 1 12 ounces beer, 1 5 ounces glass of wine, or 1.5 ounce shot of liquor, with N being at least once. I would like to ask you a question that you commonly see on an exam when you, permit exam to drive a car. So the question is this, which of the following has more alcohol in it? 12 ounces of beer, 5 ounces glass of wine, or 1.5 ounces shot of liquor? I'll put it as a multiple choice for you to answer, so go ahead. All right, so that question is commonly gotten wrong. People get them wrong all the time and choose liquor as being the most that has the most alcohol. That's false. A beer, a standard glass of wine, and a standard shot of liquor will contain the same amount of the actual alcohol. And when the alcohol is consumed, you don't consume it pure. All right, that will result in poisoning. So it's dissolved. All right, it's dissolved, and alcohol is something that is produced naturally through fermentation reactions. So the way alcohol happens in the beer, the wine or liquor is similar. It's all based on fermentation of fruits. So all of them contain the same amount of alcohol. It's just that shot of liquor is more concentrated. Is the same amount of alcohol result in a smaller amount of liquid. And we understand the notion of percentages. That means that, if you dissolved the same amount of alcohol in something that's much smaller, right, versus a beer can where the same amount of alcohol but it dissolved in the much bigger space, then this will be more concentrated, right? So that's why it feels like it has more alcohol. It's not. It's just it takes longer to drink a beer. All right, so that's why in this formula, the N, we're not substituting the amount of liquid we're drinking. We are substituting the amount of standard drinks one have, whether it's beer, wine, or shots of liquor. It's all going to be expressed as an integer. W is the weight in pounds. G is the gender constant, biological gender, 0.68 for men and 0.55 for women, and that is different, which is also something that we'll address on as we go through this lesson. And the last one is T, the number of hours since the first drink. So my question to you, number one, looking at the equation, discuss why the items on the right of the equation make sense in calculating back. All right. So I will ask you a series of questions in the form of a poll and in terms of multiple choices. So let's start first with the time variable. All right. So I'm going to ask you why the time is in this formula. Go ahead and answer that question. All right. So the time is there, which is, I think, logical, as that as more time passes by, your body will get rid of the alcohol. The liver will break down the alcohol and then get rid of it from the body. So more time passes by, the BAC will decrease. All right, so as time goes by, the blood alcohol concentration decreases, which makes sense, right, with time. All right, my second question to you, why the letter N is in the formula? Why? Why is it there? And what effect does N have on the blood alcohol content? I'll give you a moment. All right, so the N also makes sense. As N increases, blood alcohol content also increases, which makes sense, right? The more one drinks, the larger the blood alcohol content becomes. All right, how about the weight? How about the weight variable? Why is it there? What's the relationship between individuals' weight and their blood alcohol content? All right, so we can think of it this way. Assume that two people of different weight have the same number of drinks and they wait the same amount of hours, and then they get, you test with the blood alcohol content. Who will have a higher BAC content? The person with the higher weight or the one with the lower weight, given that all the other characteristics are the same? I'll give you a moment. All right, so the person who is of larger weight would mean that they have more blood, right? If you think about that way, right? Because blood alcohol content is the concentration. So then if they both have the same amount of drinks, someone of the larger weight will have a blood alcohol content smaller because it's concentrated in a larger volume. So as the weight, let me write this over here, as the weight higher, blood alcohol content is lower. And then the most surprising one in this formula is the presence of the gender constant. If you look at the numbers, it's 0.68 for male and 0.55 for female. So the constant is higher from male gender, biological gender. So how come? All right. In other words, if we look at female and male that have the same number of drinks, they have the same weight, and they spend the same amount of time after they had their first drink, who will have a higher blood alcohol content, female or male? And this is very surprising result that was also established a while ago. It's a biological result. So I'll give you a moment. Well, surprisingly, even though all of the parameters are the same, that number for female biological gender is smaller. When you're dividing by a smaller number, because it's in the denominator, your fraction is actually gets bigger. So for female, the blood alcohol content is actually going to be higher than male because of the biological factors. So again, that's something that's being discovered. So it looks like that for men, for male biological gender, the way that alcohol is breaking down by a liver is faster than for the female. All right, and that's a known fact, and that has been established there. Okay. Well, let's move on. So now let's apply this. Now we're going to do some math. Consider a case of male student who has 4 beers and weigh 160 pounds. Simplify the equation as much as possible for this case. What variables are still unknown in this equation? So let's go ahead and first copy the equation, and I'll give you a moment to substitute the numbers, and then you'll choose a multiple choice that will give you, that will give us the simplified form of this equation. All right, so let me copy this. So it's 2.84 N, and then we got W and G. All right, so go ahead, substitute all the numbers and then simplify. I'll give you a moment. Alrighty, so let's start simplifying it. So we put, we don't know the B, correct? We don't know the time, so we leave this alone. Do we know how many drinks? 4 beers, so it's 4. So I'm gonna use a different color as I substitute, so that's 4. We know weight, 160 pounds. And we know it's male, so we're gonna put a G for 0.68. All right, so to simplify is just, do on operations as possible. So you see that fraction? We're gonna multiply the numerator, we're gonna multiply the denominator, and we're simplifying it. So I'm using my calculator. 2.84 times 4 gives me 11.36. 160 multiplied by 0.68 gives me 108.8. And if we divide 11.36 by 108.8, I get, and let's use 3 places, 0.104. All right, so our simplify equation, I'll write it here because we're going to use it in question 3, is B equals to negative 0.015 T plus 0.104. All right, so that's our equation. All right, let's move on. Now it says use your simplify equation to find or the estimated or estimate the BAC for that student after 1, 3, and 5 hours when he had the first drink. Okay, so what are we going to do to answer this question? Let me ask you that in a poll. Okay, so here we need to substitute the hours. Okay, so we got 1, 3, and 5. So to do so, we're going to make a table. We're going to put the time as our input, and we're going to put B as the output, and we're going to be substituting. So we got 1 hours, 3 hours, and 5 hours. I'm going to help you with the first one, and I'll ask you to select the choice that you will get once you put the numbers in the calculator. So we're going to put minus 0.015 multiplied by 1 plus 0.104. All right, now do this operation carefully. Here, I pulled up the scientific calculator here, so you're really careful when you're substituting it. All right, I'm not sure what calculator you're using, but I strongly suggest, since we are fully online, use a Decimal Scientific calculator, the one that you see on the screen. Our last chapter in this course will be computational, so we will be using calculator extensively. We've been using it for the whole class, but here we'll be using for formulas. So we see lots of not a lot, but some formulas. So let's use it correctly. So let's begin. We want to put negative 0.015. I like this calculator because I can put exactly what I see as I'm typing it in, and I ensure that it's all correct. You see, very convenient. Use decimals. So it's 0.089. All right, so now I'm going to give you a moment to substitute the other two. Go ahead. All right, so let's review. So if you substitute 3, you get 0.059. And if you substitute 5, you get 0.029. All right, so what do you notice about the back? All right, right, it's going down. Very good. Can we say a little bit more? Do you notice anything about the way it's decreasing? I'll give you a moment. Yes, the way it goes down is it decreases by the same amount. So if you look at the difference, it decreases by 0.030. Look at the numbers. Okay, 0.030 every, how long? Look at the numbers right here. Every 2 hours. I'm going to show you something really cool, which we'll then be able to see it in the next chapter, in the very first lesson. So I'll try to remember to get back to it and say, okay, did we see this before? And we did. Well, we see it now. Check this out. Once you divide this, decrease can be expressed as a minus sign. And we can write that as a rate. Remember how we talked about the rates in this chapter, in this modulus? We're talking about fractions, rate, how things change. So here, 0.030 divided by 2 is going to be negative 0.15 every hour. And check this out. You see this right here? And you see this right here? We already knew it from the equation. All right? This is called a rate of change. It's called a rate of change. We see it in the beginning of the chapter 5, rate of change. And that tells us how fast something decreases with unit of time in this case. So here it goes. So as time goes by, the blood alcohol is being broken down in a person's body at the rate of 0.015% each hour. All right, so now check this out. It's question 4. It says it's a discuss with your group, but because we are doing this asynchronously, what I want to ask you, what operation do you do when you computed your back? Like, what did you do right here? What operation did you do? All right, and let's write them explicitly. I'll give you a moment. All right, so the first operation is multiply negative 0.015 by time. Okay, and the second operation is add 0.14 to the result. All right, so we explicitly said what we did, and now we're going to use that information to try to answer this question. It says, how long will it take for the student's blood alcohol content to reach the legal limit of 0.05? So I'm going to give you this table back. And we got 135. We're going to put the numbers, 0.89, 0.59, and 0.29. So first, I would like to ask you, between what two numbers, the back alcohol actually reaches 0.018. So when does it reach 0.0? Between what two numbers? And to help you also, you can express this decimal as 0.080, because that way it has the same number of places as this, so it's easier for you to see. Because adding a 0 at the end of the decimal doesn't change its size. All right, so between what two numbers? All right, yes, so here you see it declined from 0.089 to 0.059. So it has to happen somewhere between 1 and 3 hours. I want you to try, and I'll put it as an open-ended question, not as a multiple choice. Can you put a number specifically between 1 and 3? And it can be a decimal, like 1.8, 2.3, 2.7, whatever, that will give you exactly 0.080. Exactly. I'll give you a moment. All right, so I'm not sure. I'll review your answers, but I'm not sure if you're able to get it exactly. But finding it takes time. Means you have to input all the different t's, and we do something that's called interpolation. You try 1.1, 1.2, 1.3, 1.4, and maybe one of you, or maybe a couple of you, were able to get this. The answer ends up being 1.6. Let me demonstrate to you this. So you get minus 0.015 multiplied with 1.6 plus 0.104. So if we do this, we got, I have a calculator right here on the screen, right? So if I replace that with 1.6, I get exactly that number. And plus, if decimals, you could have just changed the numbers around and you'll get that. All right? Are you convinced with that answer? Are you happy about it? Is that the way that you find Viv? I'm just going to give a little poll to see if, how do you feel about doing it that way? Just picking an answer and getting the result that way. Well, I assume it's not convincing, right? What am I going to be there sitting down and trying different answers? But from experience teaching algebra for many, many, many years, I have discovered that doing it that way, students feel much more comfortable. They would rather sit there for an hour and pick different numbers until they get the answer. Well, now with the technology advancement, that becomes a little even unproductive. But I don't want to talk about technology. I'm interested in knowledge, right? And understanding stuff. And maybe it sparks your curiosity and brings you back to some of the times when you have seen algebra. And here where the need for it arises. So we got the equation, correct? B equals to minus 0.015 t plus the back, which is 0.104. All right, we also given information that we want the back to be 0.08, the legal limit. Well, because B is 0.08, why don't we go ahead and substitute that where it belongs, which is here. And then that becomes a mathematical equation. This is the first time in this course we see a mathematical equation. And that equation is called linear. You're going to see why it's called a linear equation when we get to the next chapter. But for now, it is a linear equation to give you some, kind of flashback to your past. Remember solving these? Remember that thing? Boom, boom. and then this stuff. Oh, oops, subtract 5 on both sides. Boom, boom, like that, and then like that. You might say, oh no, not here, not today. I don't want to do this. Well, from algebra, I don't think students have a really hard time with this. I wouldn't say that. I think the problem is a lot of times that we don't see applications of this. It's like, okay, let's solve equations. Well, here, there's some application, right? We want to know how long do we have to wait, or how long does this person needs to wait after having 4 beers to drive home? How many hours? How long should they wait to drive legally? So, we got this Widmark equation, and we can solve this. Now, I want to bring you back to here. This is what we did to find the back. So to solve the equation means to undo the operation in reverse order. So instead of going from 1 to 2, you go from 2 to 1. So back to the t, and you're reversing them as you go. So instead of adding, you're going to be doing a subtraction on both sides. So you're reversing the steps. All right, so in order to get to 0.08, we need to reverse the steps. So 0.08 minus 0.104 is, on the calculator, note the negative sign, is going to be negative 0.024. This is going to be 0.015t. And then, remember that step right here, you multiplied by negative 0.015. So opposite of multiplication is division. So you're going to divide both sides by 0.015. All right, and once you got 0.024 divided by 0.015, and that gives us 1.6. You see, that same answer. All right, be careful with the operation. This equation has decimals. Don't get thrown off at the decimals because the process of solving equations is similar. On your homework, you'll have some opportunity to solve, more traditional equation just to remind you what it's all about. But I'm hoping that these lessons give you an idea of what the equations are and under what circumstances we use them. All right. Now, by the way, just a question, just going back to the, this chapter, the beginning of this chapter. What is 1.6 hours in minutes? Can you convert this into minutes? I'll give you a moment. All right. So the way you can convert this, you use a one-step conversion. 1 hour is 60 minutes. So if you want to go from hour to minutes, you just multiply the answer by 60. So 2 hours is 140, 3 hours is 180, 1.6 hours is no different. You multiply it by 60, so you get 1.6 times 60. That equals to 96 minutes. And we know what 96 minutes means. It's 1 hour, that would be 60 minutes, and 36. An hour 36. So the person has to wait for more than that, since once it hits that mark, approximately the person's back would be, less than 0.08. And practically speaking, I would wait 2 hours if I were this person, just to guarantee that the back folds that, because Widmark equation is an estimation. That's for practical purposes. Okay, question 11. Same equation. And now what I'm asking you is find t when the back reaches 0. I'll give you a moment. Go ahead. All right, let's review. So to answer that question, now we're looking when b becomes completely 0, and we're not going to be sitting there and then looking at all different t's until we get to the 0. So what we do is we just substitute. And when we do the same 2 steps, minus on both sides, you see, subtraction first, you're doing the opposite. The order is reversed from what we did earlier when finding the b. All right, and then you take this and you divide both sides by negative 0.15, 0.15. All right, now check this out very carefully. I'm putting decimals for you here. All right, let me clear it. You put a fraction, all right, and then you have negative 0.104 divided by negative 0.015. If you're comfortable just getting rid of both the minuses, then you're fine. But here it goes. Just take your time. Use a good calculator. Don't rush. Write your steps. So t equals to 6.9 of an hour. So I would say, if I round it, I would say probably I would wait 7 hours to be safe. So if you you wait for 7 hours, it should drop down to 0. So hopefully you're feeling okay with this. All right. So it's using the formula and then getting the equation. So we have one more application and we are done. We're going to consider the case of a female student who plans to go home in 2 hours. She weighs 130 pounds. Simplify the equation as much as possible for this case, and what variables are still unknown. All right. So the information that we need, it's we're looking at female. So gender constant is 0.55, I think. Let me just go back to double check. Oh, that's far. Here we go. So gender constant is 0.55. All right, so what do we know here? All right, right, we know the time. So time is 2 hours. And we have the weight, 130. So you have all the variables, except one. And the B, we also don't know what the back is. So I'm going to give you a moment. Simplify the equation as much as possible and then select your choice. Let's review. So we got back is negative 0.015 multiplied by 2 hours. Very carefully, guys. I got 2.84, and we don't know how many drinks she had. W is 130 and G is 0.55. Now, let me highlight this. You see, this is a number, this is a number, and that is a number. So you can actually put it all inside decimals and get the simplified version of it. We can't put the n. We don't know what the n is, but we can put it aside. So check this out. I'm going to put it exactly like this. So it's a fraction. 2.84 is in the numerator. And then 130 times 0.55 is in the denominator, correct? So then we're gonna put that like that, and I'll round it to 0.040. Oops. 0.040. You round it to the 3 places right here. 0.40, because you see there's 7, so it's gonna make it a 40, and then you get the n. And then you have B equals to negative 0.03 plus. If you multiply by 2, you could get that. And there's no t anymore. There's no t. So we just get that equation. So let's write this down like this. Do not lose the negative, okay? This is a common error. When students use this equation, they forget the minus sign. The n is still unknown. So now we're gonna go ahead and see what would be her bag after 1 glass, 2 glasses, and 3 glasses. So we're going to do the same kind of thing like this. We're gonna make a table. We're gonna put n as the number of glasses, and again, it doesn't matter whether it's a wine, beer, or the shots. You're still going to substitute the whole numbers for the number of drinks. So we're going to do 1, 2, and 3. All right, now look again, substituting carefully, do not lose that minus. 0.04 times 1. I understand we can do this by hand, but I would be safe than sorry, right? So I'll substitute it exactly how I see it. All right, so that's a pretty high. So that's her back. So that's not high. This is 0.01. That's really low. So she's definitely okay to drive after one glass. It's only 0.01. All right, so now we're gonna do this for the other two. Okay, so here I put the numbers in. So what I can do on decimals and just replace that with the larger number. So 0.05. And then, so still okay to drive. Legally, okay? I mean, again, I am not saying that she should. 0.09. I'm just saying that when it comes to a legal aspect of that, alcohol and driving is really, really dangerous for the person driving and anybody who can be affected by it. It's a very dangerous and really something that we should be aware. The effects of alcohol can be lethal. So we got the numbers, right? So 0.01, 0.05, and 0.09. So here we got the place where the alcohol jumps. And we know as the number of drink increases, the back should increase. So first, my just conceptual question is, between how many drinks can she have to drive legally? So what's that range? Between what two numbers? I'll give you a moment. Well, here's where the change is, right? So from 0.05 to 0.09. So it happens somewhere between 2 and 3 drinks. To be safe, I would just say 2 is okay, and that's it. That's fine. 3 is not. So 2 is a safer bet. But if you want to just practice mathematically and determine exactly the amount that will give you 0.08, we could do this mathematically. It's possible. So you just replace 0.08 with the b, and then you get this equation. Right? And notice what you did. You first multiplied and then you subtracted, correct? You multiply first and then you subtract it. That's the order. By the way, when you're adding a negative, it's the same thing as a subtraction. So when you're solving for n, you will retract the steps. I'm going to give you a moment to see if you get an n. Round to the nearest tenth, right? One place. All right? So let's review. So we're going to add 0.03 on both sides. So that will give you 0.11. And then you'll divide both sides by 0.04. You see, you're retracting the steps. I'm going to use a calculator right here. And our answer should be between 2 and 3. So let's move this here. Let me clear this. So we got 0.11 divided by 0.04. So that gives you 275. A nice number actually, because 0.75 is 3/4 of the glass, right? So she can have 2 and then 3/4 of the glass. So 3/4 would be kind of like, this is, let's say if this is a full glass, then 3/4 would be like this, about. So we got the full and then 3/4. So that would be the amount. So I'm hoping you're feeling a little bit better with the equations. We are doing a little bit of algebra, but it's not too bad, isn't it? I'm going to see your response on the last question in the poll. All right, have a great day. We are done. See you next lesson.